Okay, we are going to get started on our notes then. So last time we worked on comp exam review and we went through all the factoring stuff, right? So this was our notes from last time. We practiced factoring. So let's take a second and remember this page. If you have that, pull that out. And let's pick one of the factoring problems and do one of the factoring problems. One thing actually I'm now remembering, we didn't get to, so the very last thing we did was special products. And we specifically did the difference of two squares. There is also the sum and difference of cubes. Usually this is not on your comp exam, but the comp exam is a little different this semester. It's on D2L, so I'm not sure if it'll be there on there or not, so I want to go ahead and show it to you. So the difference of two squares was this formula right here, right? Remember, if you have a perfect square and I'm subtracting a perfect square from it, I can factor that into 2 parentheses, 1 plus 1 minus, and take the square root. The sum and difference of cubes is a formula that you have to memorize. Other than this comp exam, there's probably not a time you're going to be using this in this course, but in other math classes you will. The sum and difference of cubes. The sum is if I have a cubed plus b cubed. So it's the sum of cubes because it has a plus sign there, and the cubes there is because they're both perfect cubes. It factors into a plus b times a squared minus ab plus b squared. The difference of cubes is the same thing, but the signs are different. Okay, so if it's a cubed minus b cubed, it factors into a minus b, a squared plus ab, and then the last sign is always the same. It's always plus b squared. Okay, so let's do one example like that. If I had the problem x cubed minus 8. That is a difference of cubes problem and not a difference of two squares. The way we know it's the difference of cubes instead of squares is because those are both perfect cubes. X cubed, you can't take the square root of it. 8, you can't take the square root. So I couldn't do this version of it, the difference of two squares, right? These are both perfect cubes though. X cubed, obviously x to the third power is x, like x cubed is x cubed. What number cubed is 8? Or what's the cube root of 8? 2, because 2 times 2 times 2 is 8. So my a and b in this problem are x and 2 that I'm working with. That's the kind of weird part about this formula. Okay, so the answer would be this formula right here. Let me go ahead and write out the formula, even though it's right there. I'm just going to go for this problem. My answer is going to look like this: a minus b, a squared plus ab plus b squared. Remember, a is x and b is 2, the cube root of 8. A and b are the cube roots of your problem. And just a reminder, b is always positive because the sign here, the minus, tells you which formula to use. We picked the bottom formula because it was a minus in the problem. Okay, so when I go to put my answer in, it's going to be a minus b, so it's going to be x minus 2. A squared is x squared plus a times b, 2x, plus b squared, 2 squared, which is 4. And that's my answer. Okay, so that's the sum and difference of cubes. Sorry, that kind of scared me. That's the sum and difference of cubes. If, again, I don't think you're going to need this semester, but just in case you do, here it is right there. Okay. So if you look at your comp exam review, we've covered all the factoring stuff, which is 1 through 3. Okay. So we just did 3, which is the cubes. So let's pick 1 or 2 to review. Which one do you want to go over? 1 or 2? 2 it is. Okay, so number 2 on the comp exam review. This is the problem that people get stuck on, and they have, sometimes they have a hard time. This one's kind of funny, but sometimes they have a hard time doing it just because they forget the formula, but it's like, the formula is pretty straightforward. This one is a little bit different. So remember I told you there were 5 different kinds of factoring. There's GCF, there's AC method, there's grouping, there's the squares, the difference of 2 squares, and then there's the sum and difference of cubes. The big rule about factoring is the first thing you have to do every single time is check and see if there's a GCF. If there is a GCF, you pull it out. If there's not a GCF, then you can go ahead and move forward. Okay, so looking at this problem, do you have a greatest common factor here? Yes, 4 and 36 both have a common factor of 4. So I'm going to pull out 4. When I factor out the 4, I get a 1. 4 divided by 4 is 1. Minus 36 divided by 4 is 9x squared. And then that inside is now, yes, sir.
Do you recommend we do like the work on a paper or separately?
This is all yours, so it's up to you. Whatever you want to do. So now that's the difference of 2 squares, right? Because it's 2 terms. It has a subtraction sign in the middle, and those are both perfect squares. Okay. So I'm gonna use the difference of 2 squares. You put the 4 in front. 2 sets of parentheses. One of them's a plus sign. The other one's a minus sign, and take the square root of everything. What's the square root of 1? 1. So I'm going to put a 1 at the beginning of both of them. What's the square root of 9x squared? 3x. And so I'm going to put a 3x at the end of both of them. And that's your answer. If you didn't take out the GCF at the beginning, you would have to take it out at the end, and it's kind of confusing because they both have a GCF and you have to pull it out of both, and it's kind of confusing. So it's really helpful if you take out the GCF at the beginning. Questions about that? Okay, so now we are going to go through some of the other problems that we need to get through. The first thing we're going to go over, this is one that should be something you remembered, but just reminding how to multiply polynomials. Okay, so multiplying polynomials is problems where it's like if you had 2x plus 3y times x minus 4y. Okay, so to multiply those, I need to multiply each part of each binomial together. And usually most people learn this as FOIL. You could learn it as just distributing. It's just however you want to. But for FOIL, you do first terms first. So I'm going to do 2x times x. What is 2x times x? 2x squared. Just a reminder, when you do x times x, it's always x squared. Outside terms is the first term times the last term on the second one. So 2x times, this is negative 4y. What's 2x times negative 4y? Negative 8xy, yx. It doesn't matter which way you put it. Now the I on FOIL is inside terms. So I'm going to do this 3y times the first thing in the other parentheses. What's 3y times x? 3yx, 3xy, it doesn't matter. I just encourage you to put them both the same so you see them as like terms, plus 3xy. And then the L is for last. What is 3y times negative 4y? Negative, there you go, 12y squared. And then at that point, you want to combine any like terms you have. like terms have the same variables with the same exponents. So which ones have the same variables with the same exponents? Yep, negative 8xy and 3xy. If you wrote one as xy and the other is yx, that's totally fine. Just you have to recognize it's the same thing. It doesn't matter which one comes first. So my answer is going to be 2x squared. Negative 8xy and 3xy is negative 5xy minus 12y squared. And that's your answer. Questions about that? Okay, so that is multiplying. Let's see, there's one of those on here. That's number 8 on your comp exam review. I'm gonna let you, we just did one very, very similar to that, so I'm gonna let you do that one. I'm gonna check them off as we've gone over them, okay? So we've gone over 1, 2, 3, and 8 now. Okay, the next one we're gonna do, let's do reducing rational expressions. So this is number 9. This kind of goes along with the factoring stuff. Okay, a rational expression is an expression that has a top and a bottom. Okay, so it's a fraction that has x's in it. So for example, if I had the problem 6x plus 8 over 2x minus 8. Minus 8. Okay, so this is a rational expression because it has a numerator and a denominator. We're going to be spending time this semester graphing these. I'm doing lots of things with rational expressions. For now, we just need to make sure that you can simplify them. So to simplify them, the thing on top, the 6x plus 8 is one whole thing. The thing on bottom, 2x minus 8 is one whole thing. So you can't just cancel out the 8s at this point, and you can't just like, you know, reduce the 6 and the 2 because the top is one thing. You can think about it in parentheses if you wanted to, and the bottom is one thing. Okay, so the way that we can simplify it is first we factor, see if you could factor anything out of it first. If you could factor something out, then you could simplify that. Okay, so look at the top, 6x plus 8. Can I factor anything out of that? A 2. When I take a 2 out, what's left over? 3x plus 4. On bottom, 2x minus 8, does that have a GCF? Yeah, a 2. What's left over when you take out a 2? X minus 4. So now you can simplify anything that's exactly the same on top and bottom. Do I have something that's the same on top and the bottom? The 2's right here. Okay, so remember these 4's, that's still a part of this whole thing. 3x plus 4 is different than x minus 4. But the 2 is the same. We can divide those out. What's 2 divided by 2? 1, and I don't need that. So it's like essentially you're canceling it out, but it's actually still dividing it out. And so your answer is 3x plus 4 over x minus 4. And that's your answer. Okay, let's do another one of those. If I had the problem 3xy minus 6x over 4y minus 8. You take a minute and see if you can factor the top and bottom, and we'll do it together in just a second. Okay, so on top, what's the GCF there? 3x. If I take out a 3x, left over from the first term is y, minus left over from the second term is 2. On bottom, what's the GCF? 4. When I take out a 4, what's left over? Y minus 2. So now what's exactly the same on top and on bottom? The y minus 2. You can cancel that part out or divide it out. And your answer would be 3x over 4. Okay, so now we've covered number 9. Next, let's do 10 and 11. Simplifying radicals. Okay, so simplifying radicals. Simplifying radicals is kind of like reducing a fraction, but with square roots and cube roots. Okay, so if I start off with the problem, the square root of 50x to the, let's do third power. Okay, so what I need to do is break this down into the prime factors. That's the little factor tree thing. So if you break down 50, give me two numbers that multiply to give me 50. 10 and 5, you could do 25 and 2. It doesn't matter where you start at, you'll end up with the same thing. Okay, that's called the fundamental theorem of arithmetic, is that you'll start off with this, or you'll end up with the same thing no matter where you start. Okay, so then we go through the prime factors. Is 10 a prime number? No, it can break down. What does it break down into? 2 and 5. Is 2 a prime number? Like, can you break down 2 anymore? No. Can you break down 5 anymore? No. This 5 up here, can you break down anymore? No. The 10 is done because I broke it down into 2 and 5. So 50, the prime factorization of 50 is 2 times 5 times 5. Okay, no matter how you start off, if you start off with 25 and 2, you'd still get 2 times 5 times 5. Okay, so I'm going to come back over here to my problem. Instead of writing 50, I'm going to write it as 2 times 5 times 5. And then x cubed, if I broke that down into the factors, what is x cubed? How many x's is it? 3 x's, yeah, x times x times x. Okay, so the rule for square roots is to come out of the square root, it has to have a partner. It has to be a pair of something. Do I have any pairs of things here? A 5. What else? A pair of x's. So I can take out the 5s and the x's. When they come out, you write what's in the pair one time. So I'm going to write 1 5 on the outside and 1 x on the outside. The reason why we do that is because what is 5 times 5? It's actually 25. When I take the square root of it, it comes out. What's the square root of 25? 5. That's the reason why you only write it 1 time on the outside, because you're taking the square root of it. And then left on the inside, what's left over? 2 and x, right? So 2x. So my answer is 5x times the square root of 2x. Let's do another one of those. What about if I had the square root of 24x to the 6th? See if you can break down 24 on your own on the outside. Again, it doesn't matter where you start. You should all end up with the same thing. You should end up with 2 times 2 times 2 times 3. You can start off with 12 and 2. You can start off with 8 and 3. You can start off with 6 and 4. It doesn't matter where you start off. You should end up with 3 factors of 2 and 1 factor of 3. Okay, so we go back and put that in our square root. So 2, 2, 2, 3. What does x to the 6th mean? 6 x's, all the x's, right? 1, 2, 3, 4, 5, 6. To come out, they come out in pairs. What pairs do I have here? A 2 that can come out. What else? A pair of x's, another pair of x's, another pair of x's, right? So on the outside, it's going to be 2 times x times x times x. What would that be? 2x cubed. On the inside, what's left over? 2 times 3, and what is 2 times 3? 6. And that's my answer. Questions about that? Okay, do this one on your own. So you can do the whole thing. The square root of 200 x squared y to the 3rd. So take like a minute and a half and do that one. Break down 200, write out your x's and y's. Okay, for this one, whenever you break it down, no matter how you start, you should get 2 times 2 times 2 times 5 times 5. X squared means 2 x's, y cubed means 3 y's. We are taking out pairs again. I have a pair of 2's, I have a pair of 5's, I have a pair of x's, a pair of y's. So all that needs to be on the outside. So what's going to be on the outside here? Yeah, 2 times 5 is 10, and then xy. And then what's left over on the inside? Just a 2 and a y. So 2y. Questions about that? Okay, let's move on to the cube root problems.
So that's like 10 and 11.
That was number 11, and now let me do number 10. So the cube root problem, it's the same exact thing. So if I had a cube root, whoops, sorry, a little 3 right here in the index. So the cube root of 192 x to the 5th y squared. For cube root, you do the exact same thing. The only difference is instead of taking out pairs of groups of two things, you're going to take out groups of three this time, like triples. Okay. So same thing. Let's break down 192. 192 is 2 times 96. '96 is 2 times 48. 48 is 4 times 12, yeah. 4 is 2 times 2. 12 is 3 times 4. 4 is 2 times 2. So going back over here to your problem, there is 1, 2, 3, 4, 5, 6 twos. So 2 times 2 times 2, 2 times 2 times 2, and 1, 3. And then there's x to the 5th y squared, so that's 5 x's, 2 y's. And you can take out groups of 3 this time because it's a cube root problem. So I have one group of 3 2's. I have another group of 3 2's. And I have a group of 3 x's. So that's what comes out. And on the outside, that's going to be 2 times 2 times x. You pick 1, 2 from each group. So 2 times 2 times x would be 4x. And then the cube root of what's left over? 3 x squared y squared, because there's 2 x's and 2 y's. So 3x squared y squared. Be really careful. Make sure you put your 3 on the cube root there. Lots of people forget that and then get it wrong. Okay, so cube root's the same exact thing. It's just you got to do groups of 3 instead of groups of 2. So that is 10 and 11 now. You can go do 10 and 11. Let's do quadratic formula next. That would be 4 and 5. Okay, so let me find that. Okay, so solving a quadratic, a problem that has x squared, and we're using the quadratic formula. There are other ways to solve quadratics. We will learn that in like 3 weeks. But for now, any quadratic you come across, you just use the quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. You will have that on your tests, on your comp exam. Yes?
Is it the only formula we're going to be giving for the comp exam?
You'll get the slope formula too. Okay, so that formula comes, the a, b's, and c's come from your problem, and your problems are in the form of ax squared plus bx plus c equals 0. So the coefficient in front of x squared is your a value. The coefficient of x is your b value, and your constant by itself at the end is your c value. And then you plug them in the formula, and the formula can come out one of 3 ways, and we're going to go over all 3 ways it comes out. So our first problem, let's do this one. 15x squared plus 4x minus 4 equals 0. Oh, that's actually number 4. That's okay. This is actually problem number 4 on your comp review page. Okay, so what's my a value here? A is 15. What's my b value? 4. What's my c value? Negative 4. Plug those into your formula. The formula says negative b. That means change the sign of b. B is currently positive 4, so I'm going to change it to negative 4. Plus or minus the square root of B squared. B is 4, so I'm going to take 4 and I'm going to square it. Minus 4 times, what's my A value? 15. What's my C value? Negative 4. All divided by 2 times A. What's my A value? 15. Be sure that your division bar goes all the way over here underneath this negative 4. Okay, sometimes people try to leave it off and then only put it under this part and it messes up your answer. The first thing you need to do is figure out what this number is under the radical. People have a hard time with this because of this minus sign. That messes everybody up. Think of it as 4 squared, and then think of it as negative 4 times 15 times negative 4. Okay, what is 4 squared? 16. And then this could be plus or minus. It just depends on what it comes out as. So now we want to do negative 4 times 15 times negative 4. You can use your calculator if you want to for this. You could do it by hand if you are really into that. So negative 4 times 15 times negative 4 is 240. Is that a positive number or a negative number? 240 right there. Does that say positive or negative? It says positive, so it is a plus sign. We are going to add 240. If you think of that as a negative 4 and multiply it in as a negative 4, your sign is whatever the sign of your answer is. Okay, that's the biggest mistake here, is that whole idea there. What is 16 plus 240? 256. So this simplifies into negative 4 plus or minus the square root of 256, all divided by 2 times 15 is 30. Okay, at this point, this is where you decide which one of your 3 options is your answer. This is option number 1. Can I take the square root of 256? You say, I don't know. So you go over to your calculator and you type in the square root of 256 and you get a beautiful, pretty whole number. Can you take the square root of 256? Yes, it is 16. So this is problem type 1. I can take the square root. So you keep on going if you can take the square root. Okay. So this becomes negative 4 plus or minus the square root of 256 is 16. You don't write your square root sign anymore because you already took the square root, over 30. That is 2 answers there. We need to break it apart and get the 2 answers. One way, or one of those problems is negative 4 plus 16 divided by 30. The other problem is negative 4 minus 16 divided by 30. So my first answer, or my first problem, is negative 4 plus 16. What's negative 4 plus 16? 12. And 12 over 30 reduces to 2/5. They both divide by 6. So 2/5. That is one answer. The other answer, what is negative 4 minus 16? Negative 20 over 30. And that reduces to negative 2/3. Okay, so that is problem type number 1, where I can take the square root of 256. If you can take the square root, you do it, add them and subtract them, get your 2 answers. Okay, the thing about this problem, if you can take the square root, this is kind of like, this isn't for your comp exam, this is just to learn in the future. If you can take the square root, that means you could have factored that and solved by factoring, which is actually a lot less work than this. Okay, the quadratic formula works every single time on every single quadratic, but is it fast or easy to do it? No. So we need it because it works all the time, but it's not always the most efficient way to do each problem. Okay, so that is one type of quadratic formula problem. Let's do one where we can't take the square root now. So if I had the problem x squared minus 7x plus 2 equals 0. Okay, so let's write what A, B, and C are again. What's my A value this time? 1. B is -7. C is 2. Let's plug it in. Negative B means change the sign of B. So +7 plus or minus the square root of B squared. So it's going to be -7 squared minus 4 times, what's my A value? 1. What's my C value? 2. All divided by 2 times 1. Do the inside first. What is -7 squared? -7 times -7? +49. That first number will always be positive because anything squared is always positive no matter what, forever and ever. Amen. Okay. You figure out the second number and if it's a plus sign or a minus sign. So -4 times 1 times 2 is -8. So that means we are going to subtract 8 from that. And what is 49 minus 8? 41. So this becomes 7 plus or minus the square root of 41 over 2 times 1 is 2. Can I take the square root of 41? No, so this is not like the problem before it. I can't keep on working it out to get two different answers. The next thing you do is you check to see if I can simplify this radical, went over to the side to break down 41, could I break down 41? I think it's a prime number. I don't think anything divides into 41 because it doesn't divide by 3. Oh, goodness. It doesn't divide by 3. It doesn't divide by 5. It doesn't divide by 7. Like, it's a prime number. So there's no way to even break it down to take anything out. So that's your answer. On Math Excel, which is where you're typing your answers in, you'll have to write it as 2 answers. What's the first answer here? Yep. 7 plus the square root of 41 over 2. What's the other answer? 7 minus the square root of 41 over 2. If you're turning something into me, you can put plus or minus, that's fine. But on Math Excel, it's going to ask for 2 answers. Okay, so that's situation number 2 is I can't take the square root. Sometimes you can simplify it a little bit more. Let me just give you like a like what it would look like if you could simplify it a little bit more. Let's say we had, let me make it up real fast. Let's say we had 4 plus or minus the square root of 24 over 2. So like this is a random new problem, okay? If we got to this point, can I take the square root of 24? You can't take square root of 24 because 4 squared is 16, 5 squared is 25. So I can't do 24. Can I break down 24? Yes. Yeah, we actually did it a little bit earlier in our notes. Where's it at? Oh, it's over here. It broke down into 2 times 2 times 2 times 3, right? So if I could break it down into 2 times 2 times 2 times 3, I'm pulling out a pair of 2's, leaving a pair of 2's in, right? So this would simplify to 4 plus or minus 2 times the square root of 6 over 2. Everybody tracking? Okay, and then you can simplify, you can divide out a common factor if all 3 outside numbers have the same factor. So these 3 outside numbers. So 4, 2, and 2, can they all divide by something? What can they all divide by? 2. So divide them all by 2. What's 4 divided by 2? 2 plus or minus. What's 2 divided by 2? 1. You could put 1 or you could just leave it as the square root of 6 over what's 2 divided by 2? 1. So you don't have to put the 1 on bottom. So it could simplify into that. Okay, so make sure if you can't take the square root of it, see if you can break it down and take anything out. Sometimes it'll simplify a little bit further. So I told you there are 3 types of answers. The first type of answer is can't take the square root. Second type of answer is, no, first type of answer was you can take the square root, keep on going, get 2 nice looking numbers without a square root. Second type of problem is you can't take the square root. It's actually a little bit easier usually because it's less work. The third type of problem is this right here. If I had 2x squared minus 3x plus 5 equals 0. Okay, my A value is 2, B is -3, C is 5. Let's plug it in. Negative B, change the sign of B. So 3 plus or minus the square root of B squared, so -3 squared, minus 4 times A is 2 times C is 5, all divided by 2 times 2. Take a second and see if you can get that number in the square root now. Okay, so -3 squared is +9. -4 times 2 times 5. -40, so it's -40. So what is 9 minus 40? -31. Okay, so this becomes 3 plus or minus the square root of -31, all divided by 2 times 2 is 4. So this is situation number 3. Can I take the square root of that? No. It's similar to the one above it, but what's different this time? It's a negative. What do I do if I have a negative in the square root? You pull it out as a imaginary number. So an I is going to be on the outside. So the answer here is 3 plus or minus I times the square root of 31 over 4. Technically, we would see if we could break down 31. Can you break 31 down to pull anything out? It's a prime number also. So -1s come out as i's and square roots. And that's your answer. So 3 situations with quadratic. Situation 1, you can take the square root. You keep on going to get 2 pretty numbers. Situation 2, you can't take the square root. Check and see if you can break it down. If not, leave it like it is. Problem number 3, you can't take the square root, but it's a negative number. Pull out the negative and write it as an I. If you left it like this, it would be wrong. You have to pull out the I. Okay, so that was problem number 4 and 5 we just finished. Okay, and next time we'll finish the last of it. We just have 4 more types of problems to go over. Okay, so you have, Tatiana asked a question real fast. She said, when you are doing your quadratic formula, we only change the sign of B on the outside, not the inside. Yes, you change the sign of this B because it says negative in front. This is just plain old B, so use the B that's in the problem. Okay. Okay, so you have some homework you can be working on still. You have 2 different review sections on Math Excel. After Friday, you can do all of it. Right now, you can do bits and pieces of each one. I don't know what problem. So pull it up. If you don't recognize how to do it, then skip it and go on to the next one. And after Friday, I'll tell you the information you need to know to take your comp exam on D2L. Okay? So if you have any questions, come see me, and I'll see you all on Friday. Thanks, sir.